Today we are going to discuss the kinetics of particles. The kinetics of particles based on a very basic law, which is Newton's second law. Newton's second law states that the summation of forces applied to a specific mass equal to the differentiation of its momentum with respect to time. In case we have the mass is constant, as we usually have in most of our cases, in most of our problems, we can say in this case that this equation equal to mass times the acceleration. This is the simplified equation of Newton's second law. Most of our problems, or you can consider all of our problems, consider the mass is constant. But in reality, sometimes the mass is not constant. Sometimes the mass varies. In some cases, in some special cases, such as missiles, aircrafts, and so on, due to the consumption or due to the fuel consumption. Due to fuel consumption, the mass is decreased. So the mass is not constant actually. In this mass, you should consider this variation and you should consider the differentiation of the whole momentum, the mass times the velocity. But in our cases, in most of our problems, we consider the mass actually is constant. So this is a simplified equation of Newton's second law. Today, we have an interesting problem that contains kinematics and kinetics in one problem. As you can recognize on the board, we have on the board two masses connected with this string, one string over two pulleys. One is fixed and one is movable. Two pulleys, one is fixed and one is movable. And we have two masses. The first one A, 200 pounds. The second one B, 350 pounds. They are connected together, as we said, through one string. There is an important assumption in this problem that there is no friction. The friction in this problem is zero. So we have not any friction forces in the problem between the string and the pulleys or between the mass A and the inclined surface. We have no friction forces in any place in the problem. Mass A, 200 pounds, moves on a surface that is inclined to the horizontal surface by 30 degrees. We have the angle between the inclined surface and the horizontal surface, 30 degrees. What is given? That we know the mass of A and the mass of B. Also, we know that there is no friction forces between the string and the pulley and between the mass A and the inclined surface. What is required in this problem? They are asking us to calculate the acceleration of each of these two masses. We need to calculate the acceleration of mass A and the acceleration of mass B. So, how we can discuss this problem? How we can solve this problem using Newton's second law? We have two masses. Each mass is subjected to different forces. We are expecting that each mass will have different acceleration. So how we can make an approach to resolve this problem? In this kind of problems, two masses, each mass is subjected to different forces. Each mass has a different acceleration and different velocities and so on. We can divide this kind of problems into two problems according to the number of masses we have. We have two masses. We can divide this problem, that including these two masses, into two separate problems, small problems. That's approach that we usually do in such cases. So, how we can use the Newton's second law to resolve this problem? We start with the reference coordinate. We should determine our reference coordinate. Let us take our positive x direction for mass A in this direction, and our positive y direction, the vertical direction, for mass B in this direction. The usual directions, x and y. Let us determine first the reference coordinates, the reference directions, the reference positive directions. Then, let us divide, as we said, this problem into two simple or small problems. Mass A, we'll draw another diagram. We call it free body diagram for mass A. As you can recognize, illustrating all the applied forces. As you can see, we have a weight, mass, the weight of mass A, MAG, that you can represent in two components. One is perpendicular to the surface, and one is parallel to the surface. One is perpendicular, the cosine component. One is parallel to the surface, the sine component. So you can represent the weight of mass A into two components, as we usually do. Represent the weight into cosine component and sine component. Do we have any other forces applied to this mass? Yeah, we also have a tension force due to this string. So we assume that we have a tension force in this direction, in the positive direction x. This free body diagram for mass A. Let us describe the forces applied also on mass B. Let us draw the mass B with all the applied forces. We have mass B 300 pounds, 350 pounds. Is subjected to a vertical weight downward, MBG, and also is subjected to two tension forces upward. So we have for mass B a downward force, downward weight, and two tension forces upward. That we have only for mass B. Let us use our Newton's second law to describe the motion of each mass, to write down the equation of motion. We start with mass A, the free body diagram. From the free body diagram, we have the tension force in this direction and the opposite force, which is the sine component of the weight of mass A. So you can write T minus MAG sine 30 degrees force minus this force. This is left side of the Newton's second law, the summation of forces in direction x. In direction x. This left side equal to the right side, which is MA, are talking about mass A, times the acceleration of mass A also. This is the first equation of motion. You can call it equation 1. That describes the motion for mass A, the first mass, 200 pounds. Let's write down also the equation of motion for mass B. The same way, we have here downward weight, downward force, MBG, downward, and we have 2 tension force upward, so we can write also 2T minus MBG, the gravitational acceleration, equal to MB times the acceleration of mass B, AB. This left side, which represents the summation of forces in direction Y. Remember, this is the positive direction of Y. So the left side represents the summation of force according to Newton's second law, and the right side of the equation represents mass times the acceleration, or the differentiation of the momentum with respect to time. You can call it this equation 2, equation 2. So we have 2 equations. How many unknowns? We have T, the same T, because as you know, we have no friction. So the tension here is the tension here is the same tension here. So T here is the same T here, the same. But we have this unknown and another 2 unknowns, A and AB, the acceleration of mass A and the acceleration of mass B. So we have 3 unknowns in these 2 equations. So we cannot solve this equation this way. We need another equation. We need to utilize some kinematics. We need to think a little about the motion of these 2 masses with respect to each other. We need to remember some kinematics for pulleys and masses. Eventually, you can recognize that the motion or the velocity of this mass, the velocity of mass A, or the acceleration, the velocity or the acceleration of mass A, equal the magnitude, absolute value of the velocity or the acceleration of mass A, equal twice the velocity or the acceleration of mass B. If you can remember the kinematics of these kind of problems, you can recognize that if this mass is going to another altitude, another height, is going to move upward for 1 meter, this mass A will move downward on this inclined surface 2 meters, because we have 2 terminals, 2 sides for the string. If this mass is going to move upward 1 meter, this mass A will be going to move downward for 2 meters. So we can deduce a small equation that the acceleration of A equal to twice the acceleration of B. the acceleration of A, mass A, is equal to twice or 2 times the acceleration of mass B. Due to the difference in directions, or due to different directions, we have this. If this mass is going to move upward in the positive direction, this mass is going to move downward in the negative directions. So we have different directions. We have difference in both directions. So we can add a minus sign here to make a balance between these two sides of equation. Anyway, we have the acceleration of A equal minus 2 times the acceleration of B from kinematics. This is the third equation. So now we can resolve these 3 equations, or actually using this third equation, we can use these 2 equations by substituting with the acceleration of A in the equation 1 and rearrange equation 1. We can rewrite down the equation 1, T equal to MA times minus 2AB plus MAG sine 30 degrees. Rearranging the equation A after we substitute with this equation. We have the mass of A, we have the mass of B. Remember that you are going to use the pound foot second units. So remember that G, the gravitational acceleration, in this case equal to 23 feet per second square. In this case, pound foot second. We are going to use the gravitational acceleration as 32 feet per second square. We have the mass of A, we have the gravitational acceleration. So we can use this equation to substitute in the second equation, in the equation 2, and rewrite down equation 2 to parentheses MA 200 times minus 2AB plus 200 times 32 times sine 30 degrees. This 2t minus MP 350 times 32, the gravitational acceleration G, equal to 350 AB. Rearrange the equation to parentheses minus 400 AB plus 200 times 32 times sine 30 degrees, close the parentheses, minus 350 times 32 equal to 350 AB. We have one equation, one unknown, which is AB. You can easily calculate the value of AB, which is AB equal to minus 4.2 feet per second square. Consequently, you can also easily calculate the acceleration of mass A, which equal to 8.4 feet per second square. These are the first two requirements. Also, you can recognize that the acceleration of B is negative, the acceleration of A is positive. You can discuss the physical meaning of these signs if you recognize that according to the shape or the weights of these two masses, we will expect that mass B will move downward according to its weight with respect to the weight of mass A. So mass B is going to move downward. So this is the opposite of the positive y direction. That's why we have negative sign here for acceleration B. Also, if this mass is going to move downward, this mass A is going to move upward in the positive direction of the assumed x-axis. So that's why we have positive acceleration of mass A. Very easily, you can also calculate the tension in the string using any of these acceleration for mass B or mass A by substituting in any of these equations. Substitute in any of these equations using the acceleration of mass B or the acceleration of mass A. You can easily calculate the tension T, which is equal to about 152 pound force. 152 pound force, or equal to 4,880 feet per second square times pound. Now we have solved the equation and we have obtained all the requirements. In the next lecture or the next session, we'll discuss another new and special problem. Stay with us, don't go far.